You might have noticed in your studies that there are many sources that answer a certain research question. When similar sources collectively represent a solution to a problem, the effect can be much more significant than an individual primary source alone. In this video, we will cover what systematic reviews are, how they are made, and how to find them. Let's start by thinking about what a literature review is, because a systematic review is a type of literature review. A literature review is a written synthesis and appraisal of evidence on a research problem. And the synthesis is a critical review and analysis of the scientific literature on a specific topic. A synthesis describes the themes of the research as they have developed across the studies in your review and over the years, including similarities and differences in purpose, content, methodology, and findings. Literature reviews apply not only to systematic reviews, but also to other primary research reports, dissertations, quality improvement projects, or other inquiries that require the use of multiple sources. Summaries aren't quite the same as syntheses because summaries are brief accounts. Syntheses, on the other hand, shows critical analysis and the integration of results. Synthesizing information from research reports carefully analyzes and reframes data to form new insight. The quality of evidence presented in a systematic review can vary based on a number of attributes, such as possible biases, heterogeneity, or how data is integrated to create new knowledge. There are over a dozen types of syntheses, but we will focus on systematic reviews. Systematic reviews also come in several types, but we'll briefly cover quantitative, qualitative, and mixed studies. Pollitt and Beck define that a systematic review carefully and transparently integrates research evidence about a specific research question using methodological procedures that are spelled out in advance. Systematic reviewers use methods that are disciplined, reproducible, and verifiable. Compared to a simple literature review, systematic reviews involve the rigorous development of and adherence to a protocol with explicit rules for gathering data from primary studies, that is, original research inquiries that address a specific question. The protocol is like a roadmap of explicit directions for a systematic review and is often published before a systematic review is carried out. The protocol includes the title of the review, members of the review team, proposed schedule, research questions, background for the review, eligibility criteria for studies in the review, search strategy, review methods, and assessment of confidence in the findings. To sum up, a systematic review is a research study of research studies. To qualify as a systematic review, a review needs to adhere to standards of transparency and reproducibility. Generally, quantitative systematic reviews have been designed to answer questions relating to therapy by integrating a number of randomized control trials, but there are other approaches to systematic reviews that address studies in etiology, prognosis, or diagnosis. Many quantitative systematic reviews include the statistical integration of a meta-analysis, which is when information from each study in the review is used to develop a common metric, an effect size. You'll often see a forest plot diagramming the statistical integration of many studies. At a glance or brief scan, a forest plot can show overall significance and generalization of studies, as well as the heterogeneity between studies. A thorough understanding of meta-analyses is beyond the scope of this video, but it can help to be aware of what a meta-analysis is, along with its strengths and limitations. It might also be helpful to bear in mind the difference between statistical significance and clinical significance. A meta-analysis may show the significance of an intervention on average, but it may not be an appropriate choice for a certain patient. Many qualitative and some quantitative systematic reviews include narrative integration, or narrative synthesis, in which integration is based on language, the use of words or text rather than numeric values. Qualitative systematic reviews often produce narrative integration in the form of metasyntheses and qualitative evidence syntheses. Metasyntheses collect phenomena or experiences, and qualitative syntheses record qualitative aspects of interventions. Mixed study systematic reviews integrate findings from both quantitative and qualitative studies. Mixed studies can show the complexity and fuller understanding of a research problem. Mixed studies also address different perspectives and provide strong and meaningful results. You might also come across other special types of systematic reviews. Scoping reviews or scoping studies are a preliminary investigation that clarifies the range and nature of the evidence base. A scoping review is broader in scope and use and can be helpful in suggesting strategies for a full systematic review. Rapid reviews are simplified versions of a full systematic review. They only take weeks to complete, where a full systematic review can take up to 2 years. Rapid reviews can help facilitate emergent decisions in healthcare settings. Umbrella reviews, also called overview of reviews, integrate findings from multiple reviews and can help filter the large amount of information generated by many systematic reviews. Living systematic reviews are types of online reviews that are updated as new research becomes available. This creates more time-sensitive reports, which otherwise are very long in making and become dated relatively quickly. It can be helpful to be familiar with these terms because they can appear in search results, studies, and discussions. You can also use these words as search terms as well. We will cover more search tips a little later in this video. Systematic reviews follow a sequence of steps similar to primary studies. They formulate a research question, define eligibility criteria for including primary studies, prepare a protocol, search and retrieve the primary studies, select studies for inclusion, assess the quality of the included studies, extract data, analyze and synthesize the data, and present the findings in a report. We'll cover each of these steps briefly. First, let's cover some preliminary steps. Prior to conducting a systematic review, it can help to know if a systematic review on topic already exists. Searching health science databases or registries like Prospero can bring awareness of reviews that have been published or those that are in process. This can also prevent redundancy in research. We'll cover more about registries in the next section about finding systematic reviews. Systematic reviews require teams of various roles. Roles include 2 reviewers to rate the quality of primary studies, a 3rd reviewer to settle disagreement, a methodological or statistical expert familiar with systematic review methods, a librarian or information specialist trained in systematic reviews, and other stakeholders such as patients or members of the public. Systematic reviews may be written independently or under the guidance of organizations such as the Cochrane Collaboration, the Joanna Briggs Institute, the Agency for Healthcare Research and Quality, or the Center for Reviews and Dissemination. For up-to-date guidance on conducting systematic reviews, see the Cochrane Handbook for Systematic Reviews of Intervention and the JBI Manual for Evidence Synthesis. See also the Preferred Reporting Items for Systematic Reviews and Meta-Analyses, or PRISMA, for helpful guidelines in developing a systematic review. A team developing a systematic review can benefit from specialized software to manage certain tasks. Some software examples include the Cochrane's RevMen and JBI Summary. Also check out the Systematic Review Toolbox for finding helpful software in creating a systematic review. As mentioned before, systematic reviews are conducted very similar to primary studies. Systematic reviews are developed from formulating the research question to presenting the findings. Let's consider each step. Like primary studies, systematic reviews can use the PICO question template. P stands for population or patients, I for intervention, influence, or exposure, C for comparison to the I component, and O for outcome. Timeframes are sometimes an additional component represented by the letter T. Chapter 9 of Pollitt and Beck shows an example that relates to the experimental intervention in quantitative studies. Suppose we hypothesize that gentle massage is an effective pain relief strategy for nursing home residents, P. The independent variable, receipt of gentle massage, can be manipulated by giving some patients the massage intervention, I, and withholding it from others, C. We would then compare pain levels, O, in the two groups to see if receipt of the intervention resulted in group differences in average pain levels. Unlike the quantitative analysis of variables that are represented by the PICO question template, qualitative studies tend to use a broader approach about meaning or processes, and often those inquiries evolve throughout the studies. Niebekon and colleagues provide a review example whose purpose was to explore how formal caregivers perceive and interpret aggressive behaviors in nursing home residents living with dementia by synthesizing knowledge from published qualitative studies. There are many other question templates you can use, but the point is to break down your research into its major components. Before searching for primary studies, initial criteria can be outlined to include sampling criteria of participants, intervention influence, study design, and other criteria such as date range, language, or items of unpublished work. Notice the similarities and differences of the sampling criteria to the PICO frame. You might notice that study design is an important part of search criteria when integrating data from similar works. Outcomes may also be included as one of the initial eligibility criteria, though the Cochrane Handbook advises that the population, interventions, and comparators in the review question usually translate directly into eligibility criteria for the review, though this is not always a straightforward process and requires a thoughtful approach, as this chapter shows. Outcomes usually are not part of the criteria for including studies, and a Cochrane review would typically seek all sufficiently rigorous studies, most commonly randomized trials, of a particular comparison of interventions in a particular population of participants, irrespective of the outcomes measured or reported. Considering possible outcomes can help organize and prioritize decisions about an intervention. A similar approach to eligibility criteria can also apply to qualitative and mixed studies reviews, depending on the aim or discovery of the study. As mentioned in the preliminary aspects of conducting a systematic review, a protocol is like the roadmap of a systematic review. Protocols document how research is operationalized. All the directions and criteria are planned in advance on a 10 to 15 page document which includes general to specific information. The protocol states the title, review team, schedule, research questions, background for the review, eligibility criteria, search strategy, review methods, and assessment of findings. Hutchinson and an interdisciplinary team provide an example of a published protocol. You might notice protocols when searching for systematic reviews, but published protocols are not the actual systematic review, they are more like plans for a proposed systematic review. While protocols are not about specific findings from primary studies, they can be helpful in planning your research about a review topic. You can find protocols registered in Prospero, Cochrane, or JBI, as well as in other health science databases such as CINAHL, Medline, PubMed, and others. The difference between research databases and registries like Prospero or clinicaltrials.gov is that the records in the registries show systematic reviews or trials that are in progress. The purpose is to provide a comprehensive listing of systematic reviews registered at inception to help avoid duplication and reduce opportunity for reporting bias by enabling comparison of the completed review with what was planned in the protocol. Likewise, clinicaltrials.gov is a website and online database of clinical research studies and information about their results. This includes studies that are happening now, will happen soon, or happened in the past. Information submitted about the study can be viewed in one place called the study record. This website and database was also once commonly referred to as a registry and results database. When preparing a search for primary studies, consider the concepts of sensitivity and specificity. Sensitivity refers to retrieving all of the relevant studies. Specificity refers to minimizing the retrieval of non-relevant studies. Sensitivity will likely produce more results, finding anything related to the search terms, while specificity will likely produce less results, excluding anything irrelevant. The concepts of sensitivity and specificity are combined with approaches to research, such as therapy, diagnosis, prognosis, causation, and others. The databases CINAHL, Medline, and PubMed include a search feature called Clinical Queries, which was developed by Shojanya and Barrow, and further utilized by the Health Information Research Unit at McMaster University. Clinical Queries divides study approaches into high sensitivity, high specificity, and best balance. To be more specific, high sensitivity in terms of database searching is defined as the broadest search to include all relevant material. It may include less relevant materials, and defines high specificity as the most targeted search to include only the most relevant set, may miss some relevant materials. Best balance retrieves the best balance between sensitivity and specificity. The PICO question, while articulating a purpose statement, can also help form a search expression for searching a database. The PICO template is generally applied to describe variables of a quantitative study, which can help organize and articulate potential search terms. Question templates can also be designed for qualitative approaches when it comes to searching the literature. Mnemonics other than PICO have been proposed for qualitative evidence searches. These include 3WH, what, topic, who, population, when, temporal, and how, methodologic. SPIDER, sample, phenomenon of interest, design, evaluation, research type, and PICO, population, phenomenon of interest, context. Aramataris and Riatano provide advice on searching related to using the PICO frame. They suggest creating a logic grid that begins as a matrix with PICO elements in 4 columns. An early step in searching is to identify alternative terms or synonyms for the concept in the grid, and to then add them into the grid. Some research databases automatically generate related terms as you enter keywords. The generated terms can be applied to a logic grid for accumulating search terms, or they can be copied and pasted in other databases that don't presently have this function. Keep in mind that there are many other ways to build search vocabulary as well, which we'll cover in the next section of this video. Other databases use the PICO frame as a search feature, such as the Cochrane Library of Systematic Reviews and the TRIP database. This can be very helpful for specifying certain variables of a study, but this may not always be the best strategy for systematic reviews. Pollitt and Beck share some caution that the use of a full PICO query may fail to retrieve all relevant articles. Ho et al., for example, found that using 2 or 3 of the PICO terms retrieved more articles than using all 4, findings similar to those of Egaritsas. Cochrane also states that it is usually unnecessary, however, and may even be undesirable to search on every aspect of the review's clinical question. Although a research question may specify particular comparators or outcomes, these concepts may not be well described in the title or abstract of an article, and are often not well indexed with controlled vocabulary terms. Systematic reviewers search multiple databases, including other sources such as Google Scholar, registries, and the use of gray literature like dissertations, theses, conference presentations, and government reports. Consider this approach to finding resources in your own work as well. You can also search specific journal titles of related content. Try using the library journal listing to search for a title. While databases search across several titles, finding one title to search through can add focus on subjects within a field. For example, the journal Systematic Reviews encompasses all aspects of the design, conduct, and reporting of systematic reviews. Another approach to searching for literature is called snowballing, also called the ancestry approach or footnote chasing, and can be a helpful search strategy based on the context of citations. Citation searching, also called the descendancy approach, is a similar search strategy in which citations can be followed from an article to the articles citing it. This can be helpful when seeking studies related to a pivotal or influential study. Certain databases have this citation search feature, such as Google Scholar, Web of Science, and Scopus. Contacting key researchers can be helpful with article requests, requesting raw data or unpublished studies. Using ResearchGate.net, LinkedIn, or a Google search can help facilitate contact. An author search of key researchers can be conducted in a database or search engine for finding related research reports or research programs. When studies have been initially retrieved, relevant articles are merged and deduplicated. Reviewers perform an initial screening of abstracts to remove irrelevant articles. The remaining articles would require further screening for eligibility criteria, in which full text would then be necessary to retrieve. Citation management software can be a very helpful tool for this process of managing primary studies. Zotero and Mendeley are two examples of free citation management software. RefWorks and EndNote are two examples of paid-for options which are sometimes provided by research institutions. The review team will have two reviewers who determine the exclusion of articles that don't meet the eligibility criteria. If the two reviewers disagree, a third reviewer is often included to resolve any conflicts. This process may vary, or may even be absent in systematic reviews. Pollitt and Beck provide an excellent search example by Capizuti in which two teams of review authors and a library specialist process over 6,000 articles. You might come across a flow diagram where selection criteria is shown as a process of excluding duplicates, irrelevant, or inapplicable primary studies. The final number of primary studies are shown at the bottom of the flowchart. You may not always find a flow diagram, though they are common and are often based on the preferred reporting items for systematic reviews and meta-analyses, which defines the often cited acronym PRISMA. Part of the screening process involves using quality assessment tools to evaluate a study's reporting methods, quality, and risk of bias. Quality assessment helps establish confidence in the findings of many studies together. There are several quality assessment scales, such as the JDAD used for randomized control trials, the Newcastle-Ottawa scale for non-randomized studies, the Robbins I, which can be used for non-randomized or randomized studies, and many more. For more details about the reliability and validity of assessment scales, consider checking out a series of articles by June, Stern, Deeks, and Altman. Unlike scales which combine information to a single numeric value, checklists can measure quality of studies based on domains or components. A few examples are the Joanna Briggs Institute Critical Appraisal Tools, the Cochrane Risk of Bias Tool, and the Acrobat NRSI for non-randomized studies. Not all systematic reviews include a quality assessment tool, but if you do find one, the study is more likely to be effective in its purpose toward clinical use, integration, or further study. As Greenhalgh mentions, if the systematic review has been properly conducted, the results are likely to be robust and generalizable. On the negative side, systematic reviews can replicate and magnify flaws in the original studies. It may be a challenge to find a specific quality assessment tool because many systematic reviews do not include one or might not have a specific tool you're looking for. If you're searching a database for a systematic review with quality assessment in mind, consider a combination of broader search terms such as quality assessment, quality evaluation, or quality appraisal. Use a drop-down menu for seeking terms in all of the text. You might notice that quality assessment is often described in the context or has a section where a specific quality assessment tool is used and cited. Once the primary studies have been selected for integration, study characteristics and findings must be extracted. Extracting data from primary studies can be done using basic forms for codifying the information or directly put in productivity applications, such as spreadsheets or designated software like Cochrane's RevMen. Data included from primary studies would include authors, publication date, design, methodology information, measurement issues, quality appraisal, data related to interventions, results, and findings. Depending on the review, characteristics of studies will vary. For instance, quantitative studies will likely collect measures of significance, while qualitative studies may collect narrative-based themes. If some data is not included in primary studies, reviewers can contact authors for specific data sets. ResearchGate.net, LinkedIn, or Google searching can be helpful resources to find a researcher's contact information. A table of study characteristics is often found in systematic reviews and is based on the extracted data from primary studies. Chapter 5 of Pollitt and Beck describe more fully the role of a literature review summary table, also referred to as a matrix, and is described as the creation of two-dimensional data collection forms, matrices or evidence summary tables, in which rows are used for individual studies and columns are used to insert relevant data about each study, such as sample characteristics, methodologic features, and results. Two-dimensional tables can provide insight into important themes in the data across studies. Pollitt and Beck further mention that the scrutiny of such tables can tell us not only what has been done, but can also point to gaps or problems. Matrices are not always included in the documents of systematic reviews. However, some are stored as supplementary material, which can be found at the publisher's website where the article is listed. When data gathering is complete, reviewers analyze the data for insight, such as the effects of an intervention measured in quantitative studies or in the themes that emerge from qualitative studies. Quantitative studies synthesize data either statistically using a meta-analysis or narratively using the evidence summary table and discerning an answer to the question of effect. Regardless of the synthesis, reviewers look for the effect's direction, how large the effect is, and how consistent the effect is across studies. Statistical complexity of meta-analyses is beyond the scope of this video, but there are a couple of noticeable characteristics that a meta-analysis can diagram. The statistical summary for each study, heterogeneity between studies, and an overall weighted average for the pooled results is discernible through a forest plot, which is the graphical and summarized output of a meta-analysis. Meta-analyses can be generated by reviewers using designated software. See the Systematic Review Toolkit for a list of tools that aid the synthesis process. Reviewers often appraise a body of knowledge using what is called the grading of recommendations, assessment, development, and evaluations, also known as GRADE. GRADE uses a scoring system to rate the quality of evidence of a review. Another purpose of GRADE is to make recommendations for clinical guidelines. The GRADE rating is applied to randomized controlled trials, so it's generally used for quantitatively based systematic reviews. Information from GRADE can be managed using software called GRADE Pro. More information about GRADE can be found at the GRADE Working Group's website and JBI's page titled What is GRADE? Similar to the GRADE rating system, JBI developed Conqual for rating qualitative evidence synthesis, which rates reviewer confidence of each study. Another example of qualitative confidence rating is the GRADE Kirkwall, which stands for the confidence in the evidence from reviews of qualitative research. The GRADE Kirkwall rates 4 aspects for each of the findings: methodological limitations, coherence, data adequacy, and relevance. Systematic reviews are outlined like primary studies. Greenhall explains the outline in that most papers appearing in medical journals are presented more or less in standard format: introduction, methods, results, and discussion, abbreviated as IMRAD. The introduction explains why the authors decide to do the research. Methods go through how they did it, and how they chose to analyze their results. The results explain what they found, and the discussion explains what they think the results mean. The Cochrane Handbook, JBI, and PRISMA, as mentioned earlier, offer very helpful guidelines in presenting systematic reviews. There are other guidelines that fit approaches to reviews as well. Another set is called MOOSE, which stands for Meta-Analysis of Observational Studies in Epidemiology, which is an example of guidelines for writing systematic reviews based on studies on causation. For more information about assessing methodological quality or reporting quality, see the article by Pusagoda and colleagues titled Identifying Approaches for Assessing Methodological and Reporting Quality of Systematic Reviews, a Descriptive Study. Let's review some key attributes of a systematic review. A flowchart is often included to help diagram the inclusion and exclusion criteria and reads like a filtering process as items are removed. PRISMA provides a helpful format for creating one, though reviewers may vary their choice of guidelines and formatting. The selected primary studies are then assessed for their study quality to determine the confidence of the findings. This would include using a quality assessment tool which comes in the form of scales or checklists, rating bias or other aspects of primary studies. Examples of quality assessment tools include the JDAD scale, Newcastle-Ottawa, Robbins-I, the JBI quality assessment checklists, and the Cochrane Risk of Bias tool. A task in conducting a systematic review is to extract data from the selected studies. This is often clearly laid out using a table, often called a matrix, based on the creation of two-dimensional data collection forms, matrices, or evidence summary tables, in which rows are used for individual studies and columns are used to insert relevant data about each study, such as sample characteristics, methodologic features, and results. Two-dimensional tables can provide insight into important themes in the data across studies. Here are some examples. Now, some systematic reviews may not provide a matrix table, though other reviews may provide one in the supplementary material found in the publisher's web page if it is not laid out in the context of the document. You might also find a reference to Prospero when a review is registered, the use of PRISMA guidelines, databases used for searching articles, and the reviewers involved in screening articles. There are plenty more details to a systematic review, but those are some things to look for. Being familiar with these attributes can help you search for and evaluate systematic reviews. Now let's consider where to find a systematic review. Let's first look at registries, but before we do, let's consider the difference between a registry and a database. Generally, registries are lists of official records with electronic search functions like databases or search engines. Registries, in the context of health science, relate to populations affected by certain diseases or clinical studies. They are described as collections of large amounts of data about a particular disease or patient population, such as trauma or cancer registries or records of studies in progress. The Autoimmune Research Network is an example of a patient registry and explains that patient registries are online databases created to look for patterns in treatments, side effect management, and diagnostics that may lead to improved treatment options and outcomes for patients. For more examples, see the National Institutes of Health list of patient registries. Our focus will be about prospective registries of study protocols of systematic reviews or clinical trials. Prospective registries hold records of systematic review protocols or trials that are in progress. Prospero states that its purpose is to provide a comprehensive listing of systematic reviews registered at inception to help avoid duplication and reduce opportunity for reporting bias by enabling comparison of the completed review with what was planned in the protocol. Likewise, clinicaltrials.gov explains their purpose in that studies are generally submitted to the website that is registered when they begin, and the information on the site is updated throughout the study. In some cases, results of the study are submitted after the study ends. This website and database of clinical studies is commonly referred to as a registry and results database. The Institute of Medicine also states that confirming the need for a new review is consistent with the committee's criterion of efficiency, because it prevents the burden and cost of conducting an unnecessary duplicative SR, systematic review, unless the duplication is considered necessary to improve on earlier efforts. Some other examples of registries include the National Institutes of Health Reporter, the World Health Organization's International Clinical Trials Registry Platform, the JBI Systematic Review Register, and the Cochrane Library. Note also that some journals will not publish trials unless they've been registered. Let's try searching Prospero. Here is an example of searching about care for refugees in the following expression: care or treatment in parentheses, with asylum or refugees in parentheses. We can use filters to add focus to the search, such as searching terms within titles. This way we can possibly match research concepts with terms connected to theses. On the right side of the results page, you can find out the status of the reviews, whether they're ongoing, completed, or otherwise. ClinicalTrials.gov is another example of a prospective registry which is based on records of clinical trials. Similar to Prospero, we can view the status of a study and manage other viewing options. Now let's find systematic reviews from research databases. We can search by entering the topic concepts using synonymous and related terms and include the study design. In this case, we'll search for systematic reviews. Databases tend to connect or map search terms to subjects, title, abstract, and other information. But we might notice other types of review articles in our results which may not pertain to the specific review we are looking for. One way to help add focus to our search is to use the drop-down menu on the right side of the text box, where Systematic Review is typed, and select the title option. This way we can find reviews that are specifically identified as systematic reviews in their title, indicating that a systematic review followed PRISMA or similar guidelines, which produce definitive and transparent methods and results. This search may not necessarily reflect publication standards or represent all existing quality systematic reviews on a topic, but it can be a helpful option to begin with. You may also consider searching for key attributes of a systematic review, such as the tools used for quality appraisal or risk of bias. Certain terms are sometimes found only within headings or paragraphs, but we can search for terms within the context by selecting a drop-down menu option for all text, using terms related to quality assessment tools, such as quality assessment, study quality, quality appraisal, or risk of bias. We could also search for specific assessment tools such as the JDAD scale, Newcastle-Ottawa, Robbins I, or others, but that may limit your search to only a few of many existing assessment tools. Also bear in mind that some quality assessments in articles may not be screened using a specific assessment tool you are considering. Now let's try searching Medline, which is another health science database. We can start by clicking on the CINAHL link that leads to different databases and switch to Medline, which will provide a similar set of articles. Details of each database can be found in the library list of databases as well. Now, we might be looking for systematic reviews based on narrative descriptions, either because a meta-analysis wasn't feasible, or for finding qualitatively produced integration or other types of syntheses. We may want to omit articles with meta-analyses by selecting the Not operator on the drop-down menu on the left side of the text box where meta-analysis is entered and selecting the title. You might even consider using the All Text options, but keep in mind that context can vary. We can also search for systematic reviews on the advanced search page using the search option for publication type. Notice the differences between a title search and publication type search for systematic reviews. The results can vary depending on how records are organized, so try different ways of searching. Let's now try a search example from PubMed. You might notice that the layout is different from other databases, and this is partly because it works on a different search system. Instead of re-entering all of our search terms, we can use the same search terms from our previous searches and make modifications as needed. We can use the keyword systematic review in a title search, or we can use filters on the left side of the search results, one of which shows article types where we can select systematic reviews. PubMed Central is another source to consider searching, which is a part of PubMed. The difference is that PubMed Central is a smaller collection, but it contains all full-text articles. You might also notice a difference in the search layout, although the search functionality is very similar. The following search shows a set of results that can help supplement your searches in PubMed. It can be helpful searching PubMed and PubMed Central separately for different functional points of view in search results. One detail worth mentioning is that PubMed and PubMed Central have similar search capabilities when it comes to searching through full text. PubMed uses a search field called text words for searching through title, abstract, and other details. PubMed Central uses a similar search field called text word, which includes all words and numbers in the title, abstract, and article body, as well as other details. You may notice the availability of full text in library databases. However, when library databases or other sources do not provide full text, Google Scholar, as found in the full text link, can often provide options. Full text options will appear as links on the right side of the screen. If Google Scholar doesn't provide an option, the library's interlibrary loan form allows researchers to make a request for about a 3 to 5 business day return, though policies and timeframes can vary. It can help to be familiar with different search options, functions, and layouts, because those variables can affect the outcome of a literature review. If you have any questions, please reach out. You can chat, call, email, or meet by video. Talk to you soon.